The next application of integrals that we're going to talk about deals with exponential functions, so growth and decay models. So just to remind you, we used exponential functions a lot with financial growth, right? If you have money in an account that you're earning interest on, it's going to grow exponentially. And if it's being compounded continuously, then it grows using base E, right? So just to remind you, if I want to calculate future value of a certain amount that I invest, it's equal to the initial value that I invest multiplied by E to the KT, where K is your interest rate. So that's my future value formula. So let's say I had a spare $36,500, and I wanted to invest that in a bank that will earn me 3% interest. Okay. Well, that's easy enough to set up an equation for, right? That gives me this equation, 36,500 e to the 0.03t. And let's say I wanted to invest it for 4 years. Well, all that means is I'm going to plug in 4 for t. And when I crank that out in my calculator, I get $41,153.64. So that's how much I'm going to have in my account after 4 years if I invest this much at 3% interest. But let's say that I don't just want to invest it once. If I've got a continuous, or if I'm making money every year, then maybe I have a spare $36,000 every year. Personally, no, that's not true. But let's say, yeah, I've got a spare $36,500 every year, so I'm going to invest that every year. Well, my initial investment will be worth this much after 4 years, but now let's look at the next year. So year 2. So year 2, I'm going to invest another $36,500. Same bank, so I'm still going to make 3% interest, but since I'm investing in year 2, how many years does it have to actually grow? It's got this year, the next year, and then the 4th year. So this amount only has 3 years to grow. So what will that give me? That's going to give me $39,937.36. And then if I invest another amount, if I invest $36,500 during the second year, after the second year, that amount will only have 2 years to mature before I'm going to look at the amount in it. Well, what is this starting to look like a little bit? The initial $36,500 will mature to this amount. The next amount that I put in will mature to this amount. The third amount that I put in will mature to this amount. If I want my total amount after 4 years, what am I going to do with all of these? I'm going to add all of these together. What is this starting to feel like? It's starting to feel like finding the area under the curve, right? Where you're finding these totals and then adding them all together. Well, so because I'm taking totals and adding them together, sure enough, this ends up being related to integrals. I can actually do all of this using an integral, where I'm taking the definite integral going from 0 to 4, because I'm looking at this 4 years from now. And since I'm looking at how much each investment matures over that amount of time, I end up with just this formula, 0.03 times 4 minus t. Why 4 minus t? Because when I start at 0, that investment has more time to mature. And when I get to my upper bound of 4, I have less time to mature. And so it's kind of going to be that inverse. So, sure enough, I can figure out my total amount by using an integral. I end up with when I actually calculate this, I get 155,121.17. Integrals are handy if I have a situation like this. What do I call this situation? This is called accumulated future value for a continuous income stream. So the whole idea behind this is, instead of just investing a certain amount of money once, I'm investing a certain amount of money every single year. Let's generalize this, okay? So I'm going to introduce a variable here, okay? Let's let R of t represent the rate of the continuous income stream. Okay, pretty much what that means is this R of t represents how much am I actually contributing every year. How much money am I putting into the account every single year? Okay, you'll notice that it can be a function of t. I could end up changing how much I contribute. I could contribute $50 the first year, $60 the next, $70 the next year, right? I don't have to always contribute the same amount. That's why it's written in function notation. Okay, and then also just be aware that T is capital T represents how many years in the future, right? The number of years it's invested. Okay, so with that in mind, to get this accumulated future value for a continuous income stream, we end up with the following integral. The integral from 0 to capital T of that rate at which the rate of the continuous income stream raised to e times k to the t minus t. Now, once again, this doesn't look the prettiest, but if I do just a little bit of exponential manipulation, I end up with this. E to the k times capital T times the integral of 0 to capital T. Remember, you might be wondering how that ended up outside. That's technically a constant because I know what k is and I know what t is. But then I have r of t times e to the negative kt dt. Now, depending on what your continuous income stream is, you're probably going to need integration by parts here. Unless we assume that my income stream is constant. So let's simplify this by just making it so I always put in the same amount. If I always put in the same amount, then, okay, so let's assume R is constant. If I always put the same amount, then I'm left with this. This integral from 0 to t of R times e to the negative kt, that's an integral that I know how to do. That's just using one simple antiderivative rule, and I end up with the following. I end up with R over k. Remember, since R is not a function, it just means I'm contributing a constant amount each year, times e to the k times capital T minus 1. And that's what I get after I actually integrate it. Okay? Very nice. And that's pretty simple. And what's nice about this is on your homework, it'll always just be a constant income stream, which actually means you don't have to integrate in this chapter at all. It's all based off of integration, but on your homework, you won't actually need to integrate because I have this formula to help me out. And there's no integration involved in this formula. Okay. So very nice. So if I apply this to what we just barely did just to see that it works, okay, so if I go back to this situation, R in my case is the $36,500 that I'm contributing each year. K is my interest rate, and then I'm going to have e to the kt, so 0.03 times t, remember, is the number of years it's invested, so in this case it's 4 minus 1. And if you plug that into your calculator, you will get the same value. You're going to get the same value out. let's look at an example from your homework. So let's say we've got some kindly grandparents who want to set up a fund, some sort of, trust fund or whatever for their new grandchild that was just born. And their goal is after 24 years, so when the child turns 24, they want $220,000 in the fund, right? Go towards a down payment for a house for them, okay? And the bank they find will give them 5.6% interest. My first question, and this is by the way, this is problem 9 from your homework. My first question is, okay, well, how much would they need to initially invest? Okay, let's first just think about it in terms of an initial investment. Okay, so that means I'm going to use my normal future value formula, P naught equal P naught e to the KT. Okay, I know what K is, right? K is 0.056. I know what T is. T is 24, right? I want this to happen after 24 years. What I don't know is what P naught is. So I'm going to keep that as P naught. But I know what I want it to end up as. I know what my future value is going to be, $220,000. Well, it turns out I can just solve for P easily enough, P naught, by just taking 220,000 and dividing by e to the 0.056 times 24, which of course I can just plug into my calculator. And I'm left with, this will give me $57,376.08. Recall, and this is a good little reminder about present value, recall that you can actually calculate this using present value by just switching it to a negative exponent. Okay, right? You can solve this by plugging the future value in as your starting point and then working backwards. So negative 0.056 times 24. And that'll give you the same value. But let's say that these poor grandparents, they don't have that much money laying around, so they can't actually make this initial investment. So instead they think, ooh, what if we just contributed a certain amount each year so that it matured to $220,000? Well, what does that sound like? That sounds like accumulated future value. So if I look at my accumulated future value formula, right, it's this R over K e to the K times T minus 1. Now, be careful, because if I'm using this formula, what am I assuming about the amount that they're going to contribute? We're going to go ahead and assume that they're contributing a constant amount each time. Otherwise, this problem becomes much more complicated. So sure enough, we're just going to assume that we are contributing a constant amount each year. Okay? We're contributing a constant amount each year. What's K? K, of course, is the interest, 0.056. T is still 24, because I want this to happen after 24 years. And what is A? A is what I want my future value to be, what I want to end up with. So in our case, it's $220,000. So you'll notice I now have an equation with only one variable that I don't know, so I can go ahead and solve for that, right? I'm going to go ahead and do 220,000 times 0.056, and then divide by all of this, e to the 0.056 times 24 minus 1. And that should give me my income stream. What do I need to actually contribute every month? And that should give you about $4,346.68. So as long as they contribute this amount, by the end of 24 years, they should have $220,000. So we just barely talked about present value as just a reminder of how else you can calculate what you need to start out with. It turns out you can also find accumulated present value of a continuous income stream. Now, what does this represent? Well, what this represents is if I contribute, say for our beginning example, if I contribute $36,500 to an account at 4% interest for 4 years, future value, of course, is what is that going to be worth after 4 years? Present value, accumulated present value, is what is that worth right now? What is that the same as investing? So, for example, this value right here represents the accumulated present value for this income stream. If that's your income stream, this is worth $57,376 at the beginning of this journey, right? At the beginning of this 24-year investment. That's as if you had $57,000. Okay? That's what accumulated present value actually means. Okay? And it turns out that you can solve for it very similarly. So accumulated present value, we use B for some reason for present value, is R over K times, but this is now just reversed. E 1 minus E, and then you have it to the negative rate. So E to the negative K times T. But recall, if I write it in this form, what am I assuming about my income stream? I'm assuming that my income stream is constant. If your income stream is not constant, so let's say as time goes on, you're able to contribute more each year, then this process becomes a little bit more complicated because you do have to go back to integrals. You have to take the integral of your non-constant continuous income stream times e to the negative kt dt. Okay? And that's probably going to require integration by parts. Luckily, none of the homework problems will have you actually do that. Okay. At this point, you guys should be plenty prepared for any of the problems on the homework, so go ahead and give them a try, and if you have any questions, please let me know. And I'll see you in the next video.